So today is the last lecture of our super fast unit on thermochemistry. We're going to be learning Big Mama. Big Mama's up there. Do you see her? She's got some rolls going on, drinking her McDonald's soda, and those are her curlers. And I basically imagine her being married to Big Daddy, but kind of goes out and cats around with Florine, the floozy, and yeah, he's kind of a bad husband, but she's kind of mean too. So every time he comes home, she's yelling at him. But anyway, Big Mama, her equation is really important because later on you're going to see how you can apply the same relationship to find the overall delta H, S, or G of a reaction using the same relationship of products minus reactants. So on your table that I just handed to you, the first column are all heats of what? Enthalpy. More specifically, what do all those tell you? For those of you at home, there's really bad things going on, or not things going on right now. I heard, what did you just say, Alex? Heat of formation. What is that? Right. So every single one of those numbers telling you the amount associated with the formation of 1 mole. Those are heats of formation. So you can take those heats of formation and plug them in, hence the reason we have F's here, into products minus reactants. Because we're only forming 1 mole in these, if there's a coefficient in the equation, we have to multiply by the coefficient, because if it's a 1, it's 1 mole. If it's not, we have to multiply by that number. So let's just go ahead and practice. Most of these that you're going to get on the test will have the table like this provided. However, when you get to college and even on your homework, you're going to have to be able to utilize one of these charts. This is a downloadable chart on the website, and it's called Thermotable. So if you don't want to use your book, some of you just can't open that book. I know it's so hard. Download the thermo chart. So to do products minus reactants, we're going to say the delta H of the full reaction is equal to the sum, that E in the equation on the page before, you know that's sigma for sum, right? The sum of the product. So let's look at our first product. 2 times, what's the heat of formation of NaOH? Negative 470. And it's the sum of those plus 1 times 0. They're being nice. I'm not going to give you the zeros. Free elements are 0. Okay, that's products minus the sum of the reactants. 2 times sodium is 0, plus 2 times water, liquid is, bless you, negative 286. So go ahead. Every single person needs to get out their calculator and try this, because this one won't be too bad, but the next problem, half of you are going to get different answers because of the way you're entering stuff into the calculator. You have to be able to enter things appropriately. Because of the ease at which you can make mistakes in this kind of thing, you need to show that setup, because it's very easy to make a mathematical error. If you don't show the setup, you can't earn any partial credit when you make an error. Not to mention, depending upon the question that this is in, the graders might look for different parts to give you credit. So say you write the right answer and give no work. You might miss the part of the question that they said, oh, did they do products minus reactants? Yes, they did. Check. If you don't have your work shown, you're not going to get that point. Did they multiply by the coefficients? If they did, they get a point. Check. Again, no work, no credit for those points, even if you have the right answer. Okay? So make sure you always show your substituted equation. And what did y'all get? Negative 68? God, 800 of you yelled it, and I still didn't hear it. I think I need to go to the doctor, get wax out of my ear. Negative 368. That would be dyslexia. Negative 368 kilojoules per mole. Now, I know it seems like these moles would cancel, but there's this big debate in the AP community about this, and it's finally been decided that any delta H of a reaction, delta S or delta G, is always going to be per mole of the reaction. in most opinions, that 2 is a mole ratio, so that should cancel out, but they don't want you to do it. So kilojoules per mole for any delta H, delta S, or delta G is always the units on your final. Okay, let's do one more. Now we're actually going to use the table. So the way the table works, it's alphabetical, and you start with the first letter in the compound. And under C, for instance, you're going to have every important compound that's going to have C in it. So we can look these up. As you find them, oxygen 0, holler them out. Be careful. States of matter. There's liquids, gases, and solids. You need to make sure you've chosen the right one. So did anyone get anything? Which is that one? Negative 393 point what? 509. Okay. Okay, good. These are all nice. All right, so this is kilojoules per mole. All right. Is that the wrong one? He chose H2O2. Positive. Negative 285 point, what 3? All right, so there's my values. Now I can plug these into Big Mama. Delta H of the reaction is equal to products, 2 times negative 393.509. Sig figs will be easier when you don't use a table. They're going to be more reasonable. Plus, it's the sum of the products times the reactant, minus the reactants. So sum of products minus sum of the reactants. Again, I want everyone to do this. People get different numbers all the time. So on a 10-point problem, if you show your work and just plug it in your calculator wrong, it might be only 3 off. If you don't show your work at all and get it wrong, it's like minus 10. Negative 13 what? Okay, let's see if we can get a second on that. Oh, you meant here? Damn it. All the money falling out of my pants. Okay. Okay. Negative 1366. All right. It's fine. Again, these sig figs aren't going to be this dramatic when you're... So it's 67. But, we could technically argue that there's supposed to be like 6 sig figs here. Why is numbers jumping? Stop. Okay. Whoa. Oh, hold on. Okay, so the last kind of problem that you're going to have, put a little asterisk by it because it's really important, is solving for this next thing here. Solving for the heat of formation of something that you don't have the heat of formation for. So looking at this problem, it says the standard enthalpy of combustion to CO2 and H2O at 25 degrees Celsius of cyclohexane is negative 3924. Calculate the standard heat of formation of cyclohexane. You can look on the chart and try to find the heat of formation of cyclohexane. It's not there. So how are we going to find it? Any ideas? Big Mama, okay. I don't know this one. How am I going to use Big Mama? What do we know? The enthalpy of what? This whole reaction. That's where you need to understand the verbiage of what we were talking about yesterday, those definitions. Standard enthalpy combustion of cyclohexane. Look at this reaction. Are we not combusting 1 mole of cyclohexane? Right? So the delta H of that entire reaction is negative 3924. Does everyone see that? So you won't catch that unless you recognize that this is a standard combustion equation. We're combusting 1 mole of something. All right, so now we're going to use Big Mama, but this is going to be a variable. This is 0. These we have on the table. So we can solve for the x. All right, so negative 3,924 kilojoules per mole is equal to product 6 times, what was CO2 gas? Negative or positive? Okay, you guys are bad about that. You have to use that number just as importantly as that negative, just as importantly, view it just as importantly as the actual number itself. Okay, I shouldn't have to ask, is it negative? And I knew it was, that's why I brought it up. 393.64? 393.509 plus 6 times H2O liquid. All right, products minus 1 times X. Are you okay if I just don't put the oxygen in there? I can't do it. Okay, so let's just go to 4 sig figs because of the 3924. On the test or quizzes, every thermo value you'll have will have the same number of sig figs, just round to that. So the heat of formation, negative heat of formation is negative 152.0, and what are my units on that heat of formation? Kilojoules per mole. Okay, a couple things I'm noticing. You're neglecting negatives, and don't forget units. Okay, got it? So we're basically done. I'm going to go back to just one problem that we did the other day. Let's look at this one real quick. I want to do Big Mama and show you how if you do Big Mama, you still get the same answer as you do when you use a flippy thing, proving that this is a state function. It doesn't matter what path you take. So remember, on this problem, this was our goal, wasn't it? Yes? No? Okay. Notice all of these were heats of formation, right? Okay. So all of these numbers are the ones you find on the chart. So we don't need to use the chart, but we're going to do Big Mama using this equation, goal equation, and those values. And hopefully we'll get the same answer. So I'm going to extend this page a little bit, and we're going to try it and test out the whole concept of Hess's law. So delta H is the reaction. It's out of my sight, so you guys are going to have to read it to me. 3 times, what's water's delta H up there? Negative 286 plus, and you need to tell me what's up there and not what's on the table, because a little bit of difference will make your answers not match up, and then you'll be like, it's not the same. CO2. Okay, products minus 1 times, what's 84? Negative 84.68 plus 0. So go ahead and do the math and verify it matches that. So we could have done that problem this way as well, if it matches. Did you get negative 1561? So again, doesn't matter what way you do it, you're going to get the same answers. So you just need to be paying attention to how they want you to solve the problem. But it's kind of cool. It's kind of cool how you can approach these differently and get the same result. All right, so my goal is for you to be done with your homework, so you have no chemistry homework this weekend. That's it.